Welcome to our latest technical deep dive, where today we are exploring the fascinating world of additive manufacturing with continuous carbon fiber reinforced polymers, a game-changing technology that's pushing the boundaries of engineering and design. If you're intrigued by the potential of additive manufacturing to create stronger, lighter, and more efficient components, then you are in the right place. Let's jump into the core challenges and innovative solutions that are shaping the future of this field. In our first segment, we delve into the unique challenges faced in additive manufacturing with continuous carbon fiber reinforced polymer. The crux of the problem lies in achieving optimal fiber orientation and distribution, a critical factor for maximizing the mechanical properties of the final part. We also highlight the persistent issues of weak interlayer adhesion, which leads to suboptimal mechanical properties and limits the potential application of this promising material. Moving on, we discuss the specific challenges of weak interlayer adhesion encountered in fused deposition modeling of continuous carbon fiber reinforced polymers. This problem significantly impacts the mechanical strength and reliability of manufactured parts, posing a hurdle for industries that demand high performance and lightweight components. Understanding this issue is key to advancing the technology and finding robust solution. Next, we introduce an exciting solution to these challenges: the load-oriented nonplanar slicing approach. This innovative method optimizes carbon fiber orientation to align with the load paths, significantly enhancing part strength and durability. Furthermore, we discuss how this approach is compatible with advanced multi-axis robotic 3D printing technologies, opening up new possibilities for complex geometries and superior structural integrity. In our final segment, we cover the optimization of parts using advanced path planning and multi-axis printing techniques. This comprehensive strategy involves identifying critical regions, optimizing vector and scalar fields, and meticulously planning the path for deposition. The results: parts that boast superior structural integrity, efficient material use, and a lightweight design. We also touch on experimental validation of this approach, underscoring its potential to revolutionize additive manufacturing. And there you have it, a glimpse into the cutting edge of world of additive manufacturing with continuous carbon fiber reinforced polymers. But this is just the tip of the iceberg. To dive deeper into this topic and explore the full extent of our research and findings, head over to our website. There, you'll find a comprehensive blog post that delves into each of these aspects in greater details. So, if you are as passionate about pushing the boundaries of technologies as we are, make sure to visit our site and read the full article. Don't forget to like, share, and subscribe to our channel for more insightful content like this. Thanks for watching, and we'll see you soon in the next video.